In this video, we're going to look at how to use the ultrasonic sensor in the GearsBot robot to turn the robot to avoid hitting the wall. Now, before we do that, let's just look at the sensor and see what it does. So we go to motion first and move the tank. Then we go to the simulator. But first, let's change the grid map to make it smaller so that we won't wait for the robot to move around the field so much. So let's say about 150, 160, that should do. Okay. Yeah, okay, so the field is smaller because we're only interested in when the robot approaches the wall. So when it's running around in the middle of the field, we don't care so much. So this will save us some time. So sensors, you click on sensors to bring up the sensors window. And you can see here into ultrasonic sensor over here. So that is the readout from the ultrasonic sensor. Into means that the ultrasonic sensor is connected to port 2. So the distance from the wall to the ultrasonic sensor is 76.7 centimeters. Now if you run the robot, okay, it moved 1 revolution of the wheels according to the program. So now it's 59.4. Previously was 76 something. So 1 revolution is about 18 centimeters. When the wheels turn 1 round, the robot will move about 18 centimeters. And we saw just now when we were setting up the grid, the large squares on the grid are 20 centimeters across. Okay, so look at the block again. What the program is doing is it's saying move tank because this is how, it's not saying that the robot is a tank, but this is how a tank is controlled. You change the speed of the left and the right wheels or tracks separately. You don't actually turn the wheels like in a car. That's why this is called move tank. So this one, we're moving the left wheel at 20% of full speed and the right wheel at the 20% of full speed. That means it will go straight and it will only turn for 1 rotation of the wheels and then it will stop. Okay, so it stopped. Let's just play again. Okay, it keeps on moving. Now you see the distance now is 41 centimeters. Play again. 24. 7. And now it hits the wall. And it's about 1 centimeter away. It doesn't actually get to 0 because if you take a look at the robot, I don't know if you can see it. Whoa, I don't know if you can see it. Yeah, okay, you see, okay, the purple thing on top of the robot, that is actually the ultrasonic sensor, and the white block below it, that's the light or color sensor. So that stops the ultrasonic sensor from hitting the wall to give you 0 centimeters. Okay, now a bit about the ultrasonic sensor. This is actually a real device. You can find it on some physical electronics robots, and it's also used in cars, real cars. Some cars have this backup alarm, right? If you're backing up the car to park the car, and then the back of the car gets closer to the wall, it'll go beep 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 beep. Yeah, that's an ultrasonic sensor. It uses a high-pitched sound to measure the distance. Okay, so now we've seen how it works. Let's write a program to turn the robot so that it doesn't hit the wall. Now to do that, we have to change this program. Well, for one thing, we cannot leave it for one rotation because, like we saw just now, one rotation means that the robot moves about 18 centimeters. And what we need to do is, instead of moving 18 centimeters, we want to move the robot just a little bit and then check the ultrasonic sensor to see whether it's near the wall or not. So let's say instead of one rotation, it'll be 0.2. So this will be about 3 or 4 centimeters. So you'll move 3 or 4 centimeters, and then we wanted to check the ultrasonic sensor, right? So we also need to put this in a loop because we don't want to keep on pressing play all the time. So loop, we just use the simple repeat loop. And just put a big number, let's say 1000. So what the program will do now is it will move the robot 0.2 rotations at a time, and you'll do it for 1,000 times. So for when you're writing a program, it's to keep on testing it as you make small changes. You don't want to write this huge program and then find out it doesn't work. Then it's harder to figure out which part doesn't work. So let's run this. We reset and we play. So you see the robot is jerking. So every jerk is one rotation, and it's turning a bit. Okay, now you see it, it's hit the wall. It's about 1 centimeter again. Now you saw that the robot wasn't moving very straight. That's because after moving 0.2 rotations, it breaks. So the wheels will slip a bit. So there are other ways to move the tank. I like this one because you know what's happening. You know that the robot will move for exactly 0.2 rotations, and then you can see what else the program is doing. So let's just try it with 10% of full speed. Maybe it won't slip so much. Okay, simulator, reset. Play. Okay, you can see it's moving straighter now because it's not moving so fast. So when the robot brakes after turning 0.2 rotations, it doesn't slip so much because it's not moving so quickly. So now, yeah, okay, it's going close against the wall. Yes. So let's stop this. So our algorithm, right, is if the ultrasonic sensor shows that it's close to the wall, we want to turn the tank. Right? An algorithm is just your step-by-step way of solving a problem. And then from the algorithm, we translate it into code, into these program blocks. So we need a sensor, ultrasonic sensor, and then we need logic. We need an if, because we want to check the ultrasonic sensor. We also need a comparison, because when we want to compare the ultrasonic sensor distance to a fixed value. So we take this number here, and let's say we put 5 centimeters. We'll see. Okay, so what this program does is it will loop 1000 times of moving the tank straight at 10% speed for 0.2 wheel rotations, and then it will check if the ultrasonic distance on port 2, remember just now we saw it was port 2, not port 1, is not equals to 5, is less than or equals to 5, then we want to turn the robot. So we want to turn the robot. We go to motion, move steering with direction. Let's use this one. Move steering with direction 90. So 90 degrees will turn it right. And speed 20%. Let's just keep everything standard at 10% speed. And for 1 rotation. Now this block is not actually turning the robot 90 degrees. It will turn the robot 90 degrees for 1 rotation, which may be more or less than 90 degrees. Because it's like when you're actually turning a car or a bicycle, right? You don't punch in 90 degrees and then the vehicle will turn exactly 90 degrees. What happens is that you just turn the wheel and then you watch the vehicle turn, and then when it has turned enough, you turn the wheel back and you straighten it out. So this is actually doing the same thing. We don't actually know how many degrees it's going to turn. You can do that, but you will need to use the gyro sensor. If you wanted to turn an exact number of degrees, the GearsBot has a gyro sensor that will allow you to do that, but we are not covering that in this video. Okay, so this very short, very simple program is actually very powerful because it should allow us to avoid the wall. So let's see if it works. We go to the simulator, we reset, and then we play. Okay, 60 centimeters. Remember, every time the robot jerks, it's turning 0.2 turns of the wheel. And yeah, I like doing that because that now you know exactly what the program is doing. You know that, okay, it's moving there, then it's checking the ultrasonic sensor. Now it's turning. Oh, it hit the wall a bit. Uh, yeah, it hit the wall a bit maybe, but not bad, not bad. Let's see if we can handle this. So remember, it's at 5 cm. Oh, less than 5 it turns. Yeah, it's hitting the wall. But yeah, it's not too bad. It's not too bad. So you can think of this like maybe a vacuum cleaner robot. You just want it to move around and cover the whole floor and clean it up. So we wanted to get as close to the wall as possible, right? But yeah, turning might be a problem, and now you know why vacuum cleaner robots are round and not square, so that they can turn without crashing into the wall. Yeah, okay. So let's see. Let's stop this, and yeah, let's just see what happens if we change this to let's say 10 centimeters. What do you expect will happen? Simulator, reset, play. Okay, 10 centimeters, turn. Okay. Now you see the turn is actually a bit more than 90 degrees. But that's okay because if this was actually a vacuum cleaner robot, we wanted to go off in different directions. So if it's not exactly 90, you can see that because it was exactly 90, it would hit the wall and then turn to the right, hit the corner, and then keep on turning. You will only you will only travel around the edges of the room. You will not cover the whole room. Now, because it's slightly more than 90 degrees, you can see that the angle keeps on changing. So this is actually good for covering the whole room. And if you want to make it even change even more, there's a random function we can put in so that the turn angle changes randomly. You can try that out if you want to. There are a lot of different things you can try out. For example, instead of turning, you could have the robot move all the way up until it touches the wall, right, up to 1 cm away. And then instead of turning, you can have it reverse first and then turn. You could also have the robot slow down. You could have the robot move faster first, and then if it gets closer to the wall, it starts slowing down instead of turning immediately. Yeah, so there are a lot of enhancements you can make to the program, but it seems to be working quite nicely. So it's turning, covering different areas of the floor. And we can also try different things. For example, we could make it turn, right? So it's turning right when it's close to the wall. So let's make it move in a leftward turn. To make it turn left, we need to make the right wheel faster. So let's make this 15. Okay, we want to make it a move in a leftward turn, so that when it does try to turn to avoid the wall, it will turn right, so that we know that it has started turning. Because if it kept on turning right normally, then if it saw the wall and turned right again, it'll be harder to know that it was actually trying to turn away from the wall. It may not be so clear, but okay, if you see it run, it'll be clearer. So we play. Okay, because now the right wheel is moving faster, it's moving in a curve. Now if the turn is too tight, you'll just move in a circle in the middle, and you'll never hit the wall anyway. So let's see what happens. Okay, it's nearing the wall. 10 centimeters. Oh, it's turning. So you see, it's very obvious when it's turning. Ah, okay. Still hits the wall. Because it approaches the wall at an angle. So when it turns, yeah, it can hit the wall. Okay. Yep. Aside from bumping to the wall a bit, you might prefer this this algorithm for cleaning the wall. It actually helps randomize the movement a bit also. Yep. Yeah, so that's about it. This shows you the power of this robot. With just a few lines of code, you can make rather clever. So you can try different things. Change the speeds, change the rotations, change the ultrasonic distance, change the steering direction, make it more complicated, make it reverse, make it slow down. There's a lot you can do. So thank you for watching. Have fun playing with GearsBot.